Hello, this is Mark Summers from Summers Technical Services. We're continuing on with our project here. This is the model I made in the last video. I went in and constrained these sketches with the right size and diameter bolt circle that I wanted to use. And I still need to specify material, so make sure to get with your team member, choose a material, particular alloy, particular type of material, and make sure you use the same material on both parts. So I'm going to go ahead and hide the sketch because I won't be needing it when I'm doing my drawing, so I want to hide that sketch. And I've got the right file name up here. This is the bottom part, so I call it a -03. So I'm going to start my new drawing, File New. This is the new template that I just posted on Canvas. It's got MM on there, so we got a B landscape. This is the inch one we've been using. If you're doing a metric part, you need to do a metric drawing. You need to use a metric template. So I'll choose that template, say OK. And I've got my part opened up already, so it thinks I want to put a view of that. So I want to click on the part, and I want to choose the top view, and I'll place the view right there. And I'm not sure what these things are, but I want to delete them. It's some kind of annotation. Oh, dowel pin symbol. Okay. So I want to delete that. I don't want that on my drawing. And this whole call out, I'm going to delete that too. I'm going to put that in later as a whole call out. All right, so now I'm going to do some center lines and some center marks. So here my datums are going to be based on a feature of size. So I want to have center marks going, center lines going through the middle of the part where my datums B and C are going to be. And I think I want to do a section view so I can see these countersinks and counterbore holes. So maybe I'll do another drawing view. I think I'll drag this view down a little bit here. Do a section view. Where is it? Section view. Let's do that's a horizontal cut. So I want to make this cut go right through these holes right here. Maybe I'll do it down here. Prove that, and then place that view down here. Say OK. That'll be nice. I'll be able to see the counterbore and the countersink down that side view and the section view. So that looks good. And now I'm going to do a section view going maybe through these tapped holes. That might be useful. So I want to go section view and use the vertical oriented cut, and I'll choose the center of that hole to locate so I can see the threaded holes. Approve that, and there we go. I've got section views, and I can see the representation of the threaded holes. Again, I don't want this lame call out. I want to do the hole call outs later. And so now I need center lines through these holes. All the holes should have center lines in all the views. So I'm going to go back to annotation, center line, and I want a center line between those two edges and a center line between those two edges. And I'm going to stretch these things out a little bit so they extend past where the hole stops, and that's per the ASME standard. So that looks reasonable. I'll come over here and do a center line through these holes. Boom, boom, and boom, boom. All right, now I'm going to put some center marks in all my holes. So I'll go center mark and select all these holes. I want a dimension to the center marks, not to the circles. I want a dimension to the center marks. So all of these get center marks, as all holes do, per ASME Y14.5. I need two more here. Center mark, boom, boom. All right, so now let's do some datum locations. We talked in class where the datums need to be. I'm going to go to annotation, datum feature. I want this bottom surface to be datum, defining datum A. And I'm going to define datum B and C with these feature size dimensions. So I want to first put these dimensions on my part here. There's that one. There's that one. And so those are features of size because they are dimensioning to opposing faces. That's the definition of a feature of size, so I can use these feature of size dimensions to define a datum. And so I'm going to do that right now. I'll go back to datum feature, and I'm going to tie it to this dimension, place it over here. I'm going to do another one tied in this dimension, and I want to place it up here. So now this tells me that datum B is halfway between these two faces, which is that center line. And then datum C is halfway between these two faces, and that's going to be the center line right here. So now we're going to go ahead and save this thing. Save often, save as. We'll put it in the same folder as have my part. Give it the same file name. And there we go. So we're going to locate these holes, we're going to put ordinate dimensions. And so I'll do a few of these. You can do all of them, but I'll do a few of them here. Ordinate dimension. I want to select the ordinate, which is the 0 point, which is this datum here. So I want to click that center line, place the ordinate, and then as I start selecting these holes, I'm going to start getting these ordinate dimensions. And this one didn't catch on the center mark, so I want to delete this one. Try again. I want these things to be tied together, so I want to add an ordinate to this group of ordinates. So instead of going up here and doing ordinate dimension again, I want to select the ordinate, right click, and say add to ordinate. And now I want to select that center line, and it's wanting to select that section line. So I want to select this center mark, so I want to right click and say select other, and it gives me a chance to select that center mark, and that'll give me what I want. All right, so those are located, and maybe I'll do these ordinate for these tapped holes on this side. I don't want to get too crowded over here, so let me spiel that out, and I'm going to go back and do another set of ordinate dimensions. So I use the pull down ordinate dimension. There's the ordinate, and I'm going to place the ordinate over here, and I want that center mark. Look at that, I don't have a center mark on there. Got to fix that. Center mark on that hole. Did I get one down here? Yeah, I did. All right, let's try that again. Smart dimension, pull down, go to ordinate dimension, and I got to delete this and start over. Try one more time. Ordinate dimension, select the ordinate, place the ordinate, and now I'll get this hole and this hole. There we go. This one needs a 2x in front of it because those two lined up with one another. This one needs a 2x. You know the routine. And you can go ahead and do ordinate dimensions. You can pull some down on this side, maybe, you know, these 4 holes here, and then maybe pull some from the top for these tapped holes so it doesn't get too crowded. So I'll let you figure out the rest of that. Now we're going to do hole call outs for these holes, and this is easy peasy because we've already done all the hard work in the model to define these holes. So all you need to do is go to hole call out, select the hole, and you get all the dimensions. You get the through hole diameter, you get the, in this case this is the countersink diameter, and there's the angle of the countersink. You get all that for free. Here's the counterbore. Same thing. I got the through hole defined. There's a counterbore diameter, and there's the depth of the counterbore. And we'll get this. This looks like the screw clearance hole. That's for the hex bolts. And I need 2 call outs. I need a different call out for this pin. One of those is going to be a press fit, FN fit, and the other one's going to be a LC fit for a clearance hole fit. So I need 2 call outs for that. So that's pretty handy. All right, I've got the datums. These are going to have to be basic dimensions because I need my trifecta. To locate these holes, I want to define the datums. I've done that. I want to define the whole target locations with basic dimensions, which are perfect, no tolerance. So I want to select my basic, I want to select all the dimensions that locate those holes. I haven't selected all of them, but you'll get the idea. Change this to basic. Now those all have basic dimensions on them. And I'll do that for all the dimensions that locate these holes, make them all basic dimensions. So I've got datums, I've got basic dimensions, most of them, not all of them yet. You put them all on there. Now I need a feature control frame. Excuse me. So let's put a feature control frame on this call out here. So the way I do that is hover over this button. This is geometric tolerance. That's going to be my command that I get the feature control frame. So I'm going to select it. I can place this feature control frame anywhere on the drawing if I clicked, but I want it to stay tied to this hole call out. So I'm going to click on the hole call out. There it is right there waiting for me to create it. So I click on it and I just start filling out these dialog boxes. So the first thing I want to do is tell it what kind of characteristic I'm dealing with. I'm dealing with a positional characteristic to locate my holes. I'll choose that. Now I get this pop up. You can see it builds the feature control frame as I go here. So I want to make this, I don't quite know what number this is going to be yet, but maybe I'll just call it, I don't know, I'll call it 0.5 millimeters. We'll calculate this in class on Tuesday. And I want a modifier, I want a MMC modifier, because I want to allow the machinist to take advantage of bonus tolerances with these feature control frames. So I'm going to go to material condition, and I'm going to click the maximum material condition modifier. Now I need to, I've already forgot something. I need to go back and fix this range because I need to add a diameter symbol. So I need a diameter symbol in front of that because the tolerance zone for these hole locations is a diameter. And so I'm going to put the diameter symbol on there. There we go. Now I'm going to go to add datums, and I need to put them in the order of importance. In this case, datum A is the primary datum, and I'll click A's up there. I'll click add new. I'll put a B up there, capital B, capital letters everywhere all the time. Add new. You can watch it, build it as we go. C, and now I'm going to just say done. And when I approve that, this thing is now all tied together. So I'm going to have a feature control frame on all of those holes. And probably put an ISO view up here. That might be nice. Drawing, model view. There's the model. I'm going to choose an ISO view. Place that right there. That might be helpful for the machine shop to kind of see what it looks like. I think I'm missing a thickness of my part. Make sure you put all your dimensions that you need to make the part, so the machine shop doesn't have to call you on the phone on Sunday and wake you up to tell you, ask you questions about your drawing. So the hole call outs, they automatically put these quantities on there because that's how we built them. There's 2 of these counterbore holes, there's 2 of these countersink holes, there's 1 each of these dowel holes, and there's 4 of the threaded holes. I didn't do a threaded hole call out. Let's do that one to make it complete. Hole call out again. I'm going to add the, find a place that'll fit here. Maybe this will be nice here. It's going to be kind of crowded maybe, but I'll pull it over a little bit. Keep your drawing nice and tidy. And I got room to spread out here a little bit, so that looks okay. And maybe I don't like that location. Let's try that again. Let's put it down here. I got a little bit more room down here maybe. So maybe that'll go over there. Try again. Hole call out. Boom, there it is. So what is this telling me? It's telling me it's kind of crowded, isn't it? Maybe I should have put this one up there. I don't know. So here's the call out. There's 4 8.5 millimeter tap drill diameter, and you thread it with an M10 by 1.5. M10, that's a major diameter. 1.5 is the pitch of the thread. 6H is the tolerance of the thread. All that comes from the model because we defined it. We defined it in the model, and so it just rolls right over to the drawing, which is what we want. Fill out the title block using file properties. Do not double click on the title block template. Try to change the text that way. It'll muck up the template. Fill out the revision block. Add your material and finish notes as usual. And right now we've got 2 sheets, 1 of 2. If we've only got a one sheet drawing, which is the case here, just right click on sheet 2, delete it, and then that'll fix the title block so it's sheet 1 of 1. So maybe that's enough information for now. Get going on your drawing, and then on Tuesday we'll go over the calculations to come up with the tolerances for all these holes that we have information about on that spreadsheet. So by Tuesday you should have your model done, checked, and have your drawing to this point, and then we'll move on and do the calculations for the tolerances to finish up the drawing. So thanks for watching, and hope this was helpful, and we'll talk to you next week.